Are you guys done? Okay, so help me out. Let's take a look at this number, 6.84 times 10 to the negative fifth power. When you're looking at 10 to the negative fifth power, you already know that this number will get bigger or smaller? Smaller. So we move the decimal point to the right or left? Left. By how many places? 5. Very good. 1, 2, 3, 4, 5. So again. So let me rewrite that. Let me use different color. We had a 6.84. Now we are moving the decimal point to the left because it's 10 to the negative fifth power. By 5 places. 1, 2, 3, 4, 5. So where is the decimal point now? And we have these places. Right? So now we have this number. So there's no decimal point there anymore, which is 0.0000684. Right? Okay, very good. How about this one? Now we are multiplying 3.12 by 10 to the 7th power. This is a positive exponent, so we need to make the number greater or smaller than 3.12. Greater. So we need to move the decimal point to the right. So we have 0.12 here. And we move the decimal point to the right by 7 places. 2, 3, 4, 5, 6, 7. There is the decimal point. You need to fill up all of these empty spots with zeros. So your number is 312 5 zeros. 1, 2, 3, 4, 5 zeros. I'm going to put the commas. There it is. There is our number. 31,200,000. Okay. Very good. How about this one? It's a negative number, but we apply the same rule, right? So we are multiplying 10 to the 4th power, so we need to move the decimal point to the right by 4 places. Very good. So we have negative 4.08. We are moving the decimal point to the right by 4. So we're multiplying 10,000. So we need to put off that decimal point. This is negative 40800. It's negative 40,800. So pretty easy, right? Awesome. We are almost done with this, and let's consider the division of the decimals. Previously, we talked about multiplication with the decimal numbers. So for example, if we are doing 3.6 times 1.2, what did we do? We pretended these are just 4 numbers, right? So we treated these as 36 times 12 and multiplied. So 6 times 2, 12, 3 times 30 times 2, 60. So we have 72. 6 times 10, 60. 3 times 1, and 30 times 110 is 300. So 360. 100 is 132. So we treat the 3.6 as 36 and 1.2 as 12. Then we take a look at the decimal point. Since we need to divide 36 by 10 to make 3.6, we need to divide it by 10 as well. And then you need to move the decimal point to the left by 1. The same thing. To make 1.2 from 12, we need to divide that by 10, or multiply that by 110, or multiply that by 0.1, which means we need to move the decimal point again by another place to the left, right? So we can do the same thing. You can just multiply 2 times 6, 12, and 2 times 3 is 6, so it's 72. 6 times 1 is 6, 3 times 1 is 3. And you can just add them together. Then you need to see how many decimal points you are moving. 1 and 2. So we talked about that last time, right? When you are doing the division, you need to think about the same way. If you have 3.6 divided by 1.2. It's not going to be easy to do because you need to think about 1.2 times what will make 3.6. Is that easier, or you just think about 12, whole number, how many whole numbers goes in that dividend? This is so much easier, right? So we can do 3.6 divided by 1.2 this way. When you are doing the division, that means 3.6 over 1.2, right? It's a fraction, the same thing. When you're doing this fraction, it's not easy for us to deal with decimal in the fraction. So we can change this to equivalent fraction by multiplying both by 10. Then you have 36 divided by 12. So these are exactly the same. So rather than doing 3.6 divided by 1.2, 36 divided by 12 is easier because we are dealing with a whole number, right? So you can do it that way. Now we can just divide 36 by 12 and see 3 goes in, right? So that's 36. So the answer is 3. So that answer, 3.6 divided by 1.2 is 3. What if you are given 0.36 divided by 1.2? You can think about this same way. So if you are changing this to a fraction, it can be written as 0.36 divided by 1.2, right? And you can do the same thing. You can either multiply this by 10 to change the denominator as 12 and do the same thing. Multiply that by 10, then you have 3.6. So you can have 3.6 divided by 12. And you can see the dividend is the whole number, so you can just figure out how many 12 goes in here. None goes in 3, right? And then you can see 12 times 3 will be 36, right? So it will be 0.3. Okay? So that's the easiest way, I believe, because your dividend, the divisor, the denominator, the divisor is the whole number. So make the divisor the whole number. That's the easiest way. You can also think about this as changing all of the numbers, both dividend and divisor, as a whole number too. So you can also think about 0.36 divided by 1.2 by multiplying by 100 instead. Then what do we get? 36 and 12 and 120. So you can also do 36 divided by 120. Let me ask you a question. In your opinion, which one's easier for you? Dividing by 12 or dividing by 120? Which one is easier? By 12, right? So even if this makes sense too, we want to have smallest whole number. So what I want to do is, we just want to change the dividend, the divisor, the denominator, the divisor into whole number. Okay? So another example, if we are, I'm just making it up, okay? Maybe it's not divisible. Something like that. If we're going to do this one, how would you solve it? Let's put another number like this. How would you solve this? You can just change the divisor into the whole number. In order to do that, you need to multiply this by 100, right? But to make it same, you need to make this as times 100 as well. You don't have to change this to the whole number. You can just change the you can just aim to change the divisor as the whole number. But when you are doing that, you need to apply the same rule. If you multiply that by 100, you need to multiply the dividend by 100 as well. Make sense? Okay, so let's do this one. So this is the same as 248.8 divided by 4. It gets so much easier. So we can just do 248.8 divided by 4. So 4 times 6 is 24. And 4 times 2 is 8. And we have another 8 there. So put the decimal point there. And we have answer like that. Okay? Very good? Right. Even if you have a negative number, it's the same thing. So let me give you another example. If you are given a problem like negative divided by, let's put negative, let's put this positive 0.06. Try to solve this problem. How would you divide negative 0.3642 by 0.06? Okay, I want everybody to solve it. On the paper. First of all, we can decide the sign. Is it positive or negative? Negative, because it's a division of negative by positive. It's like multiplication. If you have different signs, it becomes negative. Okay, now we can just do 0.3642 divided by 0.06. It's not easy to divide by 0.06, so we're gonna change this to the whole number, which is 6. How did I change that? Multiply this by 100. So we're gonna do the same thing here. What is it? 6.42 divided by 6. So we can just do 36.42 divided by 6. And 6 times 6 is 36. And 4, well, it's not enough. So you have 0 and drop down another 2, and you have 7 there. Right? It's going to be negative 6.07. Good? Okay, so we know how to do the division as well. How do I go back? Let's share my screen. Okay. Okay, we all know about this, so we don't need to do. Okay, I want you guys to practice this one more time, and then we will move on to the next slide. So you are given 1.2032 divided by 0.32. Okay, so what's your strategy? You want to change 0.32 to what? For number 32. It means you are multiplying this by 100. Do the same thing. You're multiplying this by 100 by moving the decimal point to the right. Both of them. We good? So you have 120.32. These are exactly the same thing. right? Now you can just divide 120.32 by 32. How many 32 goes into 120? Times 4.
Three.
Right? So yeah, 3. And we have what, 96?
Yes.
Okay, subtract 96 from 120. 24. Okay, that's smaller than 32, so it's good. Now you can drop down 3 there, but you still have the decimal point here. Okay, this is close to 30 times 8 is 240, so 8 is close, but it's a little bit bigger, right? Let's go to the next number, smaller number. 2 times 7, 14. 3 times 7, 21. 324. Subtract 192. Okay, how many goes in? 6. 2 times 6 is 12. 3 times 6 is 18, so it's exactly 192. And you have 0 as the remainder. So the answer is 3.76. Pretty good? Okay. Okay, I have a couple more for you. Let's do a little bit more. Okay, so help me out. What would you do here? You want to change the divisor to the whole number. So you need to multiply by 100 for both, right? So you're moving the decimal point to the right by 2. And do the same thing to the dividend, right by 2. So we have 1316.9 divided by 13, right? We can just do 1316.9 divided by 13. So 13 goes into 13, and remainder is 0, so drop down next one, which is x 1. That is not enough to go to put 13 there, so drop down another 6 there, 16. And you have 13 times 1, 13, and subtract that by 13. So 39, and you get 3. What is the decimal point? Right here. So the answer here is 101.3. Right? How about this one? We move the decimal point to the right by 2. We do the same thing. Here was decimal point, even if it's not shown, so we can move that to the right by 2 as well. Then this is the same as what divided by 75? 900. Thank you. So we can just do 900 divided by 75. So we know that 175 goes into 90. So 75 times 1 is 75. If you subtract it, 15. It's the remainder and drop down 0. How many goes in? How many 75 goes in 150? 2. So 150. And the remainder is 0. What is the decimal point? After 900. So that's what we need here. So the answer is just 12. Everybody's good? Yay. Done. Okay. Then here is a word problem. A little bit confusing, but not too bad. Okay, so this is one of the applications that we can work on the decimal operation. Okay. So Logan went to the store and found the following prices for soda. All different sizes with different prices. A 6-pack, 500 milliliter bottles of soda cost $3.99. 10-pack, 7.5 ounce mini cans of soda cost $3.99. A 12-pack, 12-ounce can of soda cost $5.49. 24-pack, 12-ounce can, same size, of soda cost $8.99. A 2-liter bottle of soda costs $1.25. 1 liter is approximately 33.8 ounces, and 1,000 milliliter is 1 liter. Well, this is just given to you. Okay, so which size is the best buy? The best buy based solely on price per unit. So what we're doing here is we're finding price per unit. So price per unit is unit price, right? So let's see how much we pay per unit. But let's take a look at the units here. The first one, 6-pack, it's given as milliliter. Next one, it's in the ounce. Third one is in the ounce and the ounce. This is a liter. So we have 3 different units there. We need to find the same unit first. Don't you think? So I will give you the table here. You can extend the tables, the columns. So you can use this table. So write down number of bottles or cans, how many. For example, the first one, there are 6, right? 6 packs, so 6 bottles or 6 cans. And what's the bottle or can size in ounce? It's 500 milliliter. 500 milliliter is what? Half of the liter. So it says 1 liter is approximately 33.8 ounces, but we have half of that, right? So you know what comes here. So 500 milliliter should be half of the liter, which means half of 33.8 ounces. So you can write half of 33.8 in ounce here. Does it make sense? What comes here? This column for the first one? What did you guess? For the first one, a 6-pack of soda. That was 500 milliliter. So you need to write that in ounces. So you need to convert the milliliter to the ounces. What is it? Here is the key. I'm saying this again. It says 1,000 milliliter is 1 liter. So if we are given 5 milliliter bottle, it's half of a liter, isn't it? Isn't it? So we have half of a liter. So it says 1 liter is approximately 33.8 ounces. We have only half of the liter. So we need to have half of these ounces. Don't you think? What's the half of 33.8? 16.9? Yeah. So 16.9 goes in this column for the first one. And how many is the total ounces? It says 6-pack. So 6 times, what did you say? What was the number here again? 16.9. So 6 times 16.9 goes here, total ounces. So you need to multiply first column by second column to get the third column. Does it make sense? Because it's the total ounces. If you have only one bottle, you're going to have only 16.9 ounces. So you have 6-pack. So 6 times 16 times 16.9 will be here. Then how much is the total cost? Well, it is given to us. It says $3.99 here. You can just copy it down. That's the total cost. Then what is the cost per ounce? Cost per ounce means cost per divided by ounce per ounce. So you can just divide the total cost, the fourth column, divided by the third column. Then you're gonna find the cost per ounce. Okay? So you're gonna fill this up with all of these different sizes of the soda. 1, 2, 3, 4, 5 different ones. So you're gonna have 5 different rows, okay? And find the cost per ounce. I will walk around and let me know if you need any help. Yeah, this is for one of the terms. Yeah, yeah. So you can make them this one, 6. This is 6. That will be the total number of the. And then we can divide that by the total cost, which is instead of 300. Yeah, actually, cost per ounce. So cost divided by ounce. Yeah, so it is divided by. Oh, that is right. Yeah. 3.99 divided by I was in making your friend, right? Yeah. So we always start from this by the time. This. Yeah. It was really like. Yeah. It doesn't make sense, right? I don't know. Yeah. Yeah. Good. Um, for multiplication, I would like to use the calculator for, but when you are doing the division, try not to use a calculator. Okay. We're working on that. That's in the division right now. I will give you about 1 more minute. Andy, Brianna, and Lisa, are you doing okay?
Yeah.
Okay, thank you. Okay, so I will give you the answer here. Ta-da! You can check your answer with this. With the same one. So if you divided this by that, you're gonna have a really big number, and that doesn't make sense, right? Because it's cost per ounce for 1 ounce. It cannot be bigger than $3.99 because $3.90 is from how many ounces? 101.4 ounces. So you can just, mentally think that, oh, the cost for these 6 bottles, it will be about 1/100th of that, right? Because it's 100 ounces, $3.99. You can divide this by 100, and that will be approximate cost per ounce. If your number is really big, bigger than 3.99, something went wrong. Maybe you operated the other way around. Okay, so did you get the answers the same? Which one is the best buy? Which one? The 2 liter is the last one? Okay, so I see this is the smallest number. I really like this problem because it's asking you so many things. It's asking you to do the multiplication of the decimal number and division as well, and cost per unit, unit price, and also it's asking you to find the order of the decimal number too. So the problem like this is very, very high cognitive demand problem. How do you like this? Good? Okay. Awesome. Okay, let's talk about the rounding numbers. You already know the rounding numbers, so we're gonna apply the same rule about the rounding numbers. So when you are doing the rounding, for example, round some number to the nearest something, like nearest 100, for example, it's 100, okay, the 100. So if you have a number like something like that, 254,725. If I ask you to round this number to the nearest 100, you can take a look at this number and see where the 100th place is. This is the 100th place, right? Then you need to look at the next number, next digit, this number, whether it is greater than or equal to 5 or less than 5, right? If it is greater than or equal to 5, you need to round up. If it's less than 5, you need to round it down. Right? So our example, it says 720. 2 is less than 5, so you need to round it down, which means you can just drop it. And that's approximately 254,700. What did I just call this? Something, 700. When you're rounding to the nearest 100, you're going to read it as something, 100. Okay? If I ask you to round this to nearest 1,000, let's change that to 1,000. What that will be? It will be something, 1,000. Okay? So let's look at the same number again, 254,725. Thousands place is here. So you need to look at the next digit, which is 7. Hey, is that greater than or equal to 5 or less than 5? Greater than or equal to 5, so we need to round that up, which means we are adding, we are rounding that up. So we are adding another 1,000 there. So it will become 250, what thousand? 5,000. Okay, so we just read it says 255,000 because we rounded the number nearest to the 1,000. Okay, so use the same rule. If we are given 7.456, and let's round this to the nearest 100th. That's the first thing. 1 nearest 100th. So take a look at that. This is ones, this is tens, this is 100th, right? This is the 100th. So you need to look at the next digit. This is 6. It's greater than or equal to 5. So what do we do? Round that up. So that's approximately what? 7.46, which is 7 and 46 hundredths. Okay, we are reading it as 100. 7 and 46 hundredths. You following me? Okay, good. Okay, so let's look at the same number again. This time, round this to the nearest tenth. Nearest tenth. So 10th place is 4, right? You take a look at the next digit, which is 5. So do we round it up or round it down? Up. So which will be 7 point what? 5. 7.5, because we are rounding that up. 7.5. So you can see that this is 7 and 5 tenths. We are reading it as tenth. Okay? Okay, then I will just go back to these examples and you will just tell me what this answer will be. 7.4 minus 6 to the nearest unit, which means a whole number. So just 7. Is that 7 or 8? It's 7, right? So this one, 7,456 to the nearest thousand. It's gonna be 7,000 or 8,000? 7,000, right? Why am I saying this between 7,000 and 8,000? Because this number is between 7,000 or 8,000, right? So when you're looking at all of these numbers on the number line, for example, let's go back to the first number, 7.456, and we rounded this nearest to thousandth, and we got that as what? 7.4. Oh, that's I said 100. I'm sorry. It's 11,000, right? So that was 4.6. So we know this number is between 7.45 and 7.46. 7.456 is between 7.45 and 7.46. Because this is 7.450 and this is 7.460, right? Where does 7.56 go? What's right in the middle? Right in the middle, 7.455. Between 50 and 60,000 is 55,000, right? Right in the middle should be 7.455. So 7.456 will be right here. This is 7.456, right? Is this closer to 7.45 or 7.46? 7.46, right? That's how we are rounding that up. So when we are reading this nearest hundredth, we can take a look at this. Where is the number in between? 7.45 or 7.46? It's closer to 7.46. So 46,000. If you're looking at this as a whole number, it's the same thing. For example, if you are given 7,456, let's look at the part E. You're going to round this to nearest 10. Nearest 10. So we are looking at whether it is between which 10. Well, yeah, it's either between 7,450 or 7,460, because this number is between 7,450 and 7,460. What's right in the middle? 55. 7,455. For our number, 7,456 is closer to 7,460 because it's right here, 7,456. That's why we are rounding this to 7,460. Make sense? Okay. So I'm pretty sure you all know about this concept. Let's finish this one, okay, before you guys leave. rounding is not too bad, and estimating is still similar. So let's look at this example. Carly goes to the grocery store to buy items that cost the following amounts. She estimates the total cost by rounding each amount to the nearest dollar and adding the rounded number. So let's round that to the nearest dollar. Tell me, 2, 1, 6, 5, 5. Add them all together, and that will be your closest money, okay? Okay, so it will be $19. Holly's bill for car repairs was $72.80, and she has a coupon for $17.58 off. She can estimate her total cost by rounding each number. So when you're rounding that, it will be 70 and that will be 20. But take a look at this. You rounded this down and you round this up. So this number will be very, very far away from actual amount because how much you have to pay, you rounded it down. So you're paying less, but yeah. And then the coupon, you rounded it up. So your actual amount should be much bigger than this one. So this kind of rounding is not really appropriate, right? So instead, you can go round this to nearest ones instead of 10. So you can say this is about 73 and this is about 18 and take away 18 from 73, which is much, much more closer to actual amount that we are looking for. Okay? So that's it. This is the similar one, so I will skip that. Have a great weekend, and your homework for second quarter 2 is due on Monday, also the quiz. Okay? All right. Have a great weekend and stay warm.